up, Algebra 1B? Okay, so today we're going to do quadratic formula. So hopefully you had some luck in deriving the formula from the standard form of a quadratic equation. Hopefully you practiced enough, you figured it out. Even if you didn't, basically what we have is this is the quadratic formula. All it is the mathematicians who went before us said, sick of doing completing the square over and over. So they took the standard form of a quadratic and they simply solved that standard form with a, b, and c for x. That's all they did. So now they have a formula where they can just plug things in, solve them, and move on with their lives. So that's all it is. So this is the quadratic formula. X equals the opposite of b plus or minus the square root of the quantity b squared minus 4ac all over 2a. Now, that only works when you have a quadratic equation in this form. So what that means for us is we need to make sure that all our quadratics are set equal to 0, and in this form, descending order of course, and then we can pull out a, b, and c, plug them in the formula, simplify, and that's it. It would be very helpful right now if you had a calculator. I know not all of us have our calculators like this at home, so again, pull up Desmos if you need it, paper, pencil, you know all that stuff. Gather it together and let's get jamming. So what I'm going to do is I'm going to put one up here like this. So we're going to do this twice. I know, right? Twice. So here's what we're going to do. This is a factorable one. Okay, we look at that, we should know, and this is a good review for your objective quizzes next week. We know that this is a trinomial. It may factor as the product of two binomials, and in fact it does. So what I'm going to do is I'm going to do it that way first. So you know x and x, we're looking for two numbers that multiply up to -20, add up to +1. Hopefully that's fairly simple. You're looking at +5 and -4. At this point, since it's factorable, we can apply our zero product property and say, okay, x plus 5 equals 0, or x minus 4 equals 0. So solving this real quick, x equals -5 and x equals 4. So our solution to this guy right now is -5 and 4. Now, why did I do that? Well, I just wanted to show you that we've already solved quadratics like this. You know the solution to it. However, we're going to show you how the quadratic formula works. So we're going to go ahead and do this one again using the quadratic formula. So the nice thing about the quadratic formula is it works for every quadratic. Let me show you how this works. So we have a quadratic in standard form. So it's ax squared plus bx plus c equals 0. In this case, it's -20, but same thing. So here's what we're going to do. The first thing we're going to do is we're going to put down the quadratic formula. Now I have it written over here because we're going to use it. So I have it written over there. All we're going to do is identify the a, the b, and the c values and plug it in. It's that simple. So the first thing I'm going to do, and you don't have to write this down every time, but I'm going to identify it. The a term is the coefficient of the x squared, which in this case is 1. The b term is the coefficient of the x term, or the linear term, which is also 1. And the c is your constant that's following, which in this case is -20. So all I'm going to do is I'm going to plug all that into my formula. So x is going to equal. So when I look at that, formula says the opposite of b. Since b is 1, the opposite of b would be -1. Plus or minus, then you have your big ugly square root. It's actually called the discriminant. So now we're going to do b squared, which is 1 squared. Notice I'm using parentheses. That will be very necessary if b is a negative value. Minus 4 times, there's more parentheses, my a value is 1, my c value is -20. And that is all over 2 times a, which is 1. Now, we can do all this by hand. You also can use your calculator if you would like. It's up to you. So when I do this, I'm going to see -1 plus or minus. Then I have that big, long, ugly square root. Now, we can punch that straight in your calculator, and I can do that here. what I'm going to do is just put in -1. I'm not using the root. I'm just putting in this value. I'm going to have the root here. So I'm looking at, 1 squared minus 4 times 1 times -20. Now the other thing we can do, if I hit enter, I get 81. I also can look at this and say, well, 1 squared is 1. This minus 4 times 1 times -20 would be minus -80, which is plus 80. Either way, that gives me 81. And that's all over 2. Now I'm going to go ahead and take care of that square root. Hopefully we all know that the square root of 81 is 9. So at this point, since everything worked out nice and pretty, I can simplify that into two numbers. I either have x equals -1 plus 9 over 2, or I have x equals -1 minus 9 over 2. If I simplify -1 plus 9, that gives me 8 over 2, which gives me 4. This guy here, -1 minus 9 is -10, divided by 2 is -5. Notice I got the same answers that I got when I factored. That's how the quadratic formula works. Now, the only caveat is a lot of times this root won't be pretty. So we'll have to leave it in a complex number form. So let's do one that's not quite as pretty. I think you're going to find this getting very simple. Again, if you don't have your calculator, make sure you have Desmos up. Let's put one up like x squared plus 7x minus 4 equals 0. So hopefully when we look at that, we realize that would not factor. I'm trying to come up with two numbers that multiply to -4, add up to 7. So we could complete the square here, but when you do your b value, you're going to do 7 divided by 2 squared. It's going to get ugly fractions, lots of steps. This is where the quadratic formula really shines. So again, I'm going to identify my a, b, and c value. So my a value is 1. My b value is 7. And my c value is -4. Once you identify those, put it into your formula, simplify. That's it. So x equals the opposite of b, since b is 7, will now be -7. Plus or minus the square root of b squared would be 7 squared minus 4 times a is 1 times c is -4. And that's all over 2 times a, which is 2 times 1. That's it. All I did was put everything in there. So now we're going to simplify. First thing I'm going to do is I'm going to take care of that root. Again, this is where I highly recommend going to your calculator, typing that in. I've got 7 squared minus 4 times 1 times -4. When I pull all that in, I get 65. Square root of 65. All over 2. Now at this point, I'm looking at the square root of 65. If you have your TI 80, you can punch that in. Of course, 65 has no perfect square factors, so he's going to stay that way. So guess what? That's simplified. Those are your two values that make that guy work. -7 plus root 65 over 2, and -7 minus root 65 over 2. Simple enough. It's that easy. Let's do another one. Let's see if we can. Let's have x squared plus 4x plus, let's go with 10 equals 0. So I got nice, pretty numbers in there. Of course, it's not factorable. I'm looking at 5 and 2, 10 and 1. Nothing's going to factor it, so we need another way. Quadratic formula. Again, identify your a values. A equals 1, b equals 4, c equals 10. Plug that into your formula. I'm going to see x equals. The opposite of b in this case would be -4. Plus or minus the square root of b squared, which is 4 squared, minus 4 times a times c, which is 10. All over 2 times a which is 1. So now it's just a simplification thing, and a lot of it can be done in your calculator. I'm going to put what's underneath that root, that discriminant, right into my calculator. So I'm looking at 4 squared minus 4 times 1 times 10. Again, typing in it exactly as I see it. So that's going to give me -4 plus or minus. When I put this whole thing into my calculator gave me -24 all over 2. Now, we do need to deal with that. So you should be able to simplify that. We've practiced that plenty of times. So when I'm looking at the square root of -24, the first thing I realize is I got to poke my eye out. That has a negative there. So I'm going to put my eye out. Square root of 24 has the factors of 4 and 6. 4 is a perfect square. So when I square root 4, it will come out front as 2. Square root of 6 will stay underneath. And that is all over 2. Now, at this point, what happens is all of these things, this lead term here, this 4, this 2 that's outside of the root, it has to be outside of the root, and this 2 here, they're all divisible by 2. So I can reduce that. So my last step here is going to be all this stuff divided by 2. Again, that's only if there's a number in front of the root. You had a perfect square that came out. It's square rooted. If all this stuff is reducible, do it. All 3 have to be. So they're all divisible by 2. So that becomes -2 plus or minus I root 6. Now that would be all over 1, but of course there's no point in putting it all over 1. This has 2 non-real answers, and it is just that. Simple enough? Hoping that's pretty simple. Let's do one that has a coefficient in front of the x squared that is not 1. So let's do something like 3x squared plus 5x minus 1 equals 0. So the first thing here is trying to factor it. You'd have to have like a 3x and an x out front. You'd be getting into that whole mess of stuff. So that's not fun. Completing the square, you'd have to divide by 3. You're going to start getting some ugly stuff. So again, this is where the quadratic formula really shines. So again, I'm going to identify my A. A is now 3. B is 5. And C is -1. I'm simply going to plug all those things into my formula. So x equals, the opposite of B would be -5 plus or minus the square root of. B squared is 5 squared minus 4 times 3 times 1. And that is all over 2 times 3. Now we simplify. So x equals -5 plus or minus that square root. I'm going to put that into my calculator. It's actually pretty easy to do in your head as well, but I assume you guys would prefer a calculator. So I'm looking at all that, punching that in. I get 13. So this is the square root of 13. I keep making my roots way too big. All over 6. Now when I do that, I got the square root of 13, prime number, no perfect square factors, nothing I can do with that. 6, 5, there's nothing, no number out front, there's nothing I can reduce by. So guess what? You're done. See, I told you guys would like this. All right, I think we can have you try one. Of course, if it doesn't go well, you can then stop it and look at the answer. So let's put one up here. We'll keep it fairly simple. We won't even put a coefficient of, or an a term bigger than 1. So let's do x squared plus 4x plus, let's go with 9 equals 0. So pause the video, do the problem, come back, let me know what you see. Okay guys, here it is worked out. So if you got that and you feel good, go ahead and skip on, try the next example. Going through it real quick. Identified my A as 1, B is 4, C is 9. Put that into my formula. Opposite of B becomes -4, plus or minus Square root of b squared is 4 squared minus 4 times a is 1 times c is 9. And put that all over 2 times 1. Now, did anybody type this in with the root? If you do that, your calculator is going to say domain error because it can't do a square root of a negative. So make sure you're just putting that b squared minus 4ac in, no root. So when you put that all in, well, you wind up with 16 minus 36, which is negative 20. Calculator will also give you that. So I have negative 4 plus or minus the square root of negative 20 over 2. Now, square root of negative 20, that brings its own little reducing you need to do. Got to poke your eye out. You have the square root of negative. Also, 20 is 4 times 5, so the square root of 4 comes out as 2. That's why I have the 2i out in front of the 5, the root 5. And that's all over 2 times 1 is 2. Since these three things, number outside of the root, that opposite of b, and that value underneath the denominator, since they're all divisible by 2, I will reduce them. This becomes negative 2. 2i divided by 2 is just 1i, or I, root 5. And of course, I didn't put it over 1 because we don't need to do that. Hope you're okay with that. Let's try another one. Let's put a coefficient in front of that x squared. See how you do with that. Let's do 4x squared plus 7x minus, let's go with 3, equals 0. So you know the drill. Pause the video, give it a whirl. Welcome back, guys. This one, very simple. Identified my a as 4, b is 7, c is negative 3. Put it in my formula. X equals opposite of b is negative 7 plus or minus b squared is 7 squared minus 4 times a is 4, c is negative 3, all over 2 times a, which in this case is 4. Now, when I do that, punch that into your calculator, or you can do it, you wind up with the square root of 97 there. Negative 7 is still here, plus or minus root 97, and of course 2 times 4 is 8. Well, here's the thing. 97 doesn't reduce. There's no perfect square factor. Nothing can be reduced out front. There's no number out front here, and of course 7 and 8 don't have any common factors other than 1. You're done. That one's a nice and easy one. Let's try this. I want to show you that this can work for any quadratic. So let's take something like 2x squared minus, let's make it 8 equals 0. Now, what you could do is solve this with perfect squares. So we have 2x squared minus 8 equals 0. You could simply go, okay, well, I add 8 to both sides, divide by 2. I wind up with x equals plus or minus square root of 4 after I square root both sides. And I wind up with x equals positive or negative 2. Simple enough, right? Let's plug it into our quadratic formula here. A in this case is 2. Now, here's the key. B is 0. There's no b value. C is negative 8. So if I punch that into my formula, x equals, the opposite of b, well, that's just 0. Plus or minus the square root of 0 squared minus 4 times a is 2. C is negative 8. And that's all over 2 times a, which is 2 times 2. So we simplify this. The 0 plus or minus doesn't need to be there. It's just 0. So we're just going to go to the plus or minus. If I do this, 0 squared minus 4 times 2 times negative 8, punch that into your calculator if you'd like, you wind up with the square root of 64. 4 times 2 is 8. That's negative 8 times negative 8, positive 64. And that's all over 4. You all know that the square root of 64 is 8, so this becomes positive or negative 8 over 4. And of course, that becomes positive or negative 2. Works for every quadratic. I hope that was good enough. Practice it. If we have any questions, problems, concerns, we'll do a hangout, or we can do some examples for you. Give it a whirl. Your worksheet is on Canvas, quadratic formula. The key is also there. There's 2 there. I uploaded 2, I think because I gave you the packet. I wasn't sure which one I gave you. There's two different CUDA versions. So when you pull those up, make sure you check which one you have before you look at the answers and think all of your answers are wrong. So make sure you pull up the one you have in your packet. Everything was frantic when we left school, so I forget which one I put on there. So make sure you have the right one. Check your answers. Ask me any questions. Good luck. See you guys.